Welcome back. This is Mr. Greenstein's Geometry, and we're talking about Chapter 9.3. This is Part 2 of 2 parts. We're talking about similar right triangles and the geometric mean. Now, we just learned about the geometric mean the other day. Geometric mean just says that we can have x over r is equal to s over x, so that x is equal to the square root of r times s. So that's the geometric mean. And we're going to be using the fact that we have similarity between these different triangles here to get the result and see how the geometric mean works in this whole thing. So I'm just going to back up a little bit. We're going to look at the fact that we have proportional sides. So if I have proportional sides, that means that AD relates to CD. And we see that in our triangles ACD and the little triangle CBD. So CD is the same thing as AD on this. So I can say that AD relates to CD, and that's here. But we can also see that BD relates to CD here. So BD of this triangle relates to CD of this triangle here. Notice that this CD and this CD are the same length. So I have BD and CD of the two different triangles. These are the similarity ratio, or the scale factor, going from one triangle to the other triangle. And if I multiply these, or cross multiply, I get CD squared is equal to AD plus BD. In the bigger diagram, you see that CD squared is equal to this AD times this DB. If I also take a look at this small triangle and compare it to the big triangle, this BD here is, or DB, relates to CB up here. And the CB of this little triangle, which is the same as this, relates to this big AB here. So we make this relationship and we cross multiply, and we get CB is equal to DB plus AB. So this leg here squared, or this, is the geometric mean of this whole length here times this little length here. And then we can take that and look at the big triangle and the medium triangle, and we find the same type of relationships, and we find that AC, this leg, is the geometric mean of this whole leg here, AB, times AD, which is just part of it. So now we have these relationships that are the geometric mean. We can use these. The geometric mean theorem says that if we have a right triangle, just like this, where the altitude is drawn from the right angle to the hypotenuse, then it divides this into segments over here that we can use as the geometric mean of the lengths of other segments. So we're going to use we'll go back a second. The altitude theorem says that this distance here is the geometric mean of this distance and this distance. So it splits it into two segments here. This is the geometric mean of these two. If I go to the leg, I can say that this leg CB is equal to the geometric mean of this whole hypotenuse here times this portion here, this little segment here. So the geometric mean allows us to make calculations, and that's what we're going to do here in this particular problem. So let's look at A here. Y, or x, is part of this side. We can say that this leg, 20, is the geometric mean of this whole side times this little part here. So we can say that 20 squared is equal to x plus 10, that whole side, times 10. And then we can work this out. We'll take 20 squared, that's 400, divide by 10, that's 40, and then subtract 10, and x is equal to 30. So x is 30. We know that y is the geometric mean of both this segment and this segment. So we can say that y is equal to the square root of 30 times 10, which is 300, and that's going to be 10 root 3. And z works out to be very similar to that, except that it's going to be this whole length here times this length here, which is 30. So z is going to be equal to the square root of x plus 10, which is 40, times just the x part, which is 30. And then I'll let you work that out. That's the square root of 1200, and that's what z is. Now if we go over to b over here, you can see that this is the geometric mean of this and this. So we can say that the square root of 6, or yes, the square root of 6 is equal to the square root of 3 times x. If we square both sides, we get 6 is equal to 3 times x, so x is 2. And you can work out y. Y is going to be equal to, or y squared is equal to the sum of these two, which is 5, times just this portion 3. So it'll be 5 times 3, which is 15. So y is the square root of 15. And I'll leave it to you to come up with what z is going to be. The surveyor's line, this is what we use our geometric mean to its fullest potential. If you look at this problem here, we have a surveyor, and from his vantage point, the top of the cliff is up here, and the bottom is down over here. And it creates a right angle here. He draws his hypotenuse, or his altitude, to his hypotenuse, which is a straight line. And he can calculate what this distance is, because he knows that this is the geometric mean of this and this. And I'll leave it to you to come up with the calculation. And we'll discuss this in our next class.